You are welcome to the Scholar Online class.
The Scholar School, we establish our footprints on the sand of time.
Good day everyone, and you are welcome to the Scholar Online class. And today, I'll be taking you through GCE Alternative to Practical Chemistry. My name is Uncle Sam, and I'm your tutor for today. So today we'll be looking at the quantitative analysis in chemistry practical. Quantitative analysis, from the name quantitative, quanti, is trying to talk about the amount of a chemical component present in a given sample. So we'll be looking at this question today. The question says A is 0.200 mole per dm cube of HCl, hydrogen chloride. B is a solution containing 14.3 gram of Na2CO3 XH2O in 500 centimeter cube of solution. Put A into the burette and titrate it against 20.0 centimeter cube or 25.0 centimeter cube portions of C using methyl orange as indicator. Tabulate your results and calculate the average volume of A used. From your results and the information provided, calculate D. So today we'll be calculating the concentration of B in mole per dm cube, be calculating concentration of B in gram per dm cube, the molar mass of Na2CO3 XH2O, which is our B, solution B. And 4, we'll be calculating the value of X in Na2CO3 XH2O. Now, I want you to know this, that in GCE practical for chemistry, everything you need will be provided for you, which means you don't need to carry out the practical, you don't need to carry out the titration. The value will be given out to you. The purpose of carrying out the titration is to get the volume of acid used. But GCE is going to give you the volume. They are going to give you a tighter value. Lastly, prepare a table for you and which you are going to get the tighter value by yourself. So today I'm going to prepare a table and then I'm going to input the tighter value I got after carrying out this titration. Now, solution. The first thing to do when calculating or solving questions under practical chemistry, quantitative analysis, is to write out your equation of reaction first. The equation of the reaction. So we have HCl plus solution B, Na2CO3. When these two react, it gives us NaCl plus CO2, then plus our X plus 1 H2O. Now let's try and balance this equation. Let's look at sodium. We have how many moles of sodium here? We have 1 mole. And right here in the reactant side, we have 2 moles of sodium. So we balance. We have 2 moles of sodium now. Now, while balancing sodium, we've messed up with chlorine. Now we have 2 moles of chlorine. So we have to what? Balance the chlorine atom also. Carbon, we have 1 mole of carbon and we have 1 here. We have 2 moles of oxygen here, plus 1 making 3. Right here, we have 3. Now, coming to this side, X plus 1, close bracket, H2O. X multiplied by H2O will give us XH2O. And plus 1 multiplied by H2O will give us H2O to balance this hydrogen and also to complete this oxygen. Do you understand? Now, after getting the equation of the reaction, then we move on. I said I'm going to prepare a table and I'm going to input the value I got after carrying out this titration. Now, we have our right here, I have my rough titer. And I have my first titer here. Then my second titer. Are you with me? Now, here I have my final reading. And here I have my initial reading. Then here I have my average volume of acid use. Now, why carrying out this reaction? For my rough tighter, I started with 0.00 centimeter cube. I made use of the 25 centimeter cube burette. Are you with me? So my initial reading was 0.00 and my final reading was 25.10. Then my first tighter, I started with 0.080 again and I got 25.50. My second tighter, 0.00, then I got 25.60. From here, my average volume of acid used for rough tighter, 25.10 minus 0.00. I have 25.10. Here I have 25.50, and here I have 25.60. Now, after carrying out the reaction, I have my first tighter to be 25.50, 25.60, which it is what? It is accurate. Now, if it were to be a YA class, I will tell you that your tighter value, your first and second tighter value, for you to be very sure that you are correct, your tighter value must not be plus or minus 0.20. Which means if your first tighter is 25.50, then your second tighter should not exceed 25.50 plus or minus 0.20. If you are within this range, then you are still on the track. But this is GCE class, so let's go straight to the point. Now, to calculate the average volume of acid use, the formula for calculating average volume of acid use is first tighter plus second tighter divided by 2. Sometimes we might have a situation whereby we have 3 tighter. How do you do that? Your average volume of acid used will be first tighter plus second tighter plus third tighter divided by 3. But here I have 2 titers, so first tighter plus second tighter divided by 2. So first tighter plus second tighter. My first tighter is 25.50 plus my second tighter is 25.60 divided by what? Divided by 2. When you solve this and divide by 2, your answer should be 25.55 centimeter cube. 25.55 centimeter cube. So from here, we've been able to get our volume of acid. Let me put that here because I'm gonna rub the board very soon. Our volume of acid use is equal to what? 25.55 centimeter cube. 25.55 centimeter cube. So with this, we can go on to what? To start our calculation. I'm going to leave this equation on the board because we are still going to be using it. Now, let's go. The first question says, calculate the concentration of B in mole per dm cube. The first formula that should come to your mind is mole equal to what? Mass over molar mass. First check if this formula can solve your problem. What is our mole for B? Of B in mole per dm cube. That's what we are looking for. Our mass, do we have mass? Yes, we have mass. The molar mass, do we have the molar mass? We don't have it yet. So this equation, this formula, we can't use this formula. So the formula that we are going to be using is what I call Savart-Caban, which is Ca over Cb equals to Na over Nb. Very simple. Savart-Caban, CAVA over CBVB equals to Na over Nb, where your Ca is the concentration of A, 0.2. Your Va is the volume of acid used, which is 25.55 centimeter cube. Your Cb is the concentration of B in mole per dm cube that we are looking for. Your Vb is the volume of the burette you used, either 20.0 centimeter cube or 25.0 centimeter cube. Mind you, be very watchful. In your question, you might be given 20.0 centimeter cube or 25.0 centimeter cube. You might be given either of the two. Your Na is gotten from the equation. Na is the number of moles of acid, which is 2 moles. You have 2 moles for the acid. Nb is the number of moles of the base, which is 1. Are you with me? So let's input our value. Our Ca is what? 0.2. So we have 0.2 times our Va, 25.55. 25.55 all over our Cb. That's what we are looking for. So let's write it there. Our Vb, you can either make use of 20.0 centimeter cube or 25.0 centimeter cube, but I will be making use of 25. You can try this on your own and make use of 20. We'll be getting the same answer. 25.0 centimeter cube. Our Na is 2 moles. Then Nb is what? Is 1. Then you cross multiply. Use your simple mathematics. 0.2 times 25.55. Then you cross multiply this also. So we'll be having Cb times 25.0 times 2. That is 50. Is 0.2 times 25.55 will be 5.11. Then from here you what? You divide both sides by the coefficient of what? Of your Cb. And Cb is equal to 5.11 divided by 50. 5.11 divided by 50 will be equal to 0.10. Don't forget your unit, mole per dm cube. This unit is very, very important in chemistry practical. You have to put your unit, 0.10 mole per dm cube. So we've been able to solve the first question, which is 0.10 mole per dm cube. That is that for the first one. Now moving to the second one, calculate the concentration of B in gram per dm cube. The first one we calculated was in mole per dm cube. Now we want to calculate B in gram per dm cube. Now in gram per dm cube, let's go back to the question. The question says B is a solution containing 14.3 gram. B is a solution containing 14.3 gram of this. This is our B in 500 centimeter cube, which means we already have our gram in 14.3 gram, but it is in 500 centimeter cube. 500. But we need to change it to 1000 centimeter cube, which is the standard volume. You might be given 250 in your question. You might be given 250 centimeter cube or 750 centimeter cube. Either of the centimeter cube you are given. If it is not in 1000 centimeter cube or it is not in 1 dm cube, then you have to convert it to what? To 1000 centimeter cube. So it is very simple. We say 14.3 gram is equal to, or you say is given in 500 centimeter cube. How many of the gram, x gram, will be given in what? In 1000 centimeter cube. Do you understand? We were given 14.3 gram in 500 centimeter cube. Then how many unknown? How many of this gram will you get in 1000 centimeter cube? Are you with me? It's very simple. So you what? You cross multiply. So we'll be having 500 x gram equal to 14.3 times 1000. 14.3 times 1000. Then you divide both sides by what? By 500. So we have x gram equal to what? 14.3 times 1000 is what? 14,300. Then you divide both sides by what? By 500. So from here, x gram is equal to what? 28.6 gram. Your x now is equal to what? 28.6 gram. Let me recap again. I said 14.3 gram is in 500 centimeter cube. How many gram will be in 1000 centimeter cube? Then you cross multiply. We have 500x equals to 14.3 times 1000. 14.3 times 1000, you get 14,300. Then you divide both sides by what? The coefficient of x, which is 500. Then our x is what? 28.6 grams. Are you with me? Now you should, it is a very simple mathematics. You should even like assume you are given 14.3 in 500. 500, you have 500, 2 times in 1000. 14.3 times 2 will give you what? 28.6. So for this, we have this to be what? 28.6 gram. Now let's calculate the molar mass. Now we want to calculate the molar mass of what? Of Na2CO3X-H2O. Now let's calculate molar mass of Na2CO. Now we are going to use the first formula. The first formula I mentioned earlier, which is mole equals to what? Mass over molar mass. Our mole equal to mass over what? Over molar mass. Now, what is our mole? We've gotten the what? We've gotten the mole, and which is what? 0.10. Now, our mass, we've gotten the mass in 1000 centimeter cube. You are not going to be using this mass because it is not in the standard form, which is 1000 centimeter cube. So, our mass is what? 28.6 gram. We are looking for this. Are you with me? So, let's input our value. What is our mole? 0.10. 0.10 equal to our mass 28.6 gram. 28.6 gram. Then our molar mass is what we are looking for. You can represent that with what? X. So you cross multiply. We have 0.10x equals to 28.6 gram. Then you divide both sides by what? By the coefficient of x. So x is equal to what? 28.6 divided by 0.10. When you divide 28.6 by 0.10, you should be getting 286 gram per mole. Don't forget, your unit matters a lot. 286 gram per mole. So our molar mass, the molar mass of Na2CO3X-H2O is what? 286 gram per mole. So we've been able to solve the first question, the second. Now the third is what? 286 gram per mole. Now let's go to the last question, which is the fourth question. The question says we should calculate the value of X in this compound Na2CO3X-H2O. You will agree with me that this is very abnormal. This kind of equation is very abnormal. So we want to calculate the value of X. Why are we having X here? So we want to calculate the value of what? The value of X. So you say, what is the molar mass of Na2CO3? 286. So you say 286 gram per mole is equal to Na2CO3X-H2O. Are you with me? Now we have we are given the parameters. We have Na to be what? 23. We have carbon to be what? 12. Oxygen to be what? 16. Hydrogen 1. Oxygen 16. So let's do that now. So we have 286 gram per mole equal to, what is our Na? 23 times 2. We have 2 moles of sodium there. Don't make the mistake of adding 23 plus 2. No, we multiply. So we have 23 times 2 plus our carbon is what? 12 plus 16 times 3. 16 times 3 plus our X. Let me come down here and write it. Plus our X. Our H is what? Hydrogen. 1 times 2 plus oxygen is what? 16. Are you with me? So right here we have 286 equal to 23 times 2 is what? 46. So we have 46 plus 12 plus 16 times 3. 6 times 3 is 18. 8, 1. 3 times 1, 3. Plus 1, 4. So we have 48 plus, now look at this, 1 times 2, 2, plus 16, that's 18. X multiplied by 18 is what? 18x. So we have plus 18 what? X. So let's add this together. So we have 286 equal to 46 plus 12 is what? Is 60. 60 plus 48, 108. So we have 108 plus what? 18x. So from here we what? We collect like times. We move this 108 to the other side. So we are having 286 minus 108 equal to what? 18x. 286 minus 108, we are having 180 equals to what? 18x. Divide both sides by what? 18. So our x is equal to what? 10. Our x, final answer, is equal to 10. Now let's check to see if we are correct with this. If we are correct, everything here, Na2CO3 H2O, should sum up to what? 286. Now from here, Na2CO3 is what? 108. Right? Now let's put our x. Let's replace this x with 10. We have 10. 10 times 18, that's 180. 180 plus 108 will give us 286. So we are correct. Our x is equal to what? Is equal to 10. There is no magic in everything. Now let me recap. We've been able to calculate the concentration of B. And I said, first thing first, in chemistry practical, you have to what? Write out the equation of the reaction, which we've done justice to. And then I said, for GCE, you'll be given everything. Your information will be provided to you. There is no need for you to carry out any practical. Everything will be provided for you. And then we calculate the concentration of B. And we said the concentration of B is what? 0.10 mole per dm cube. Concentration of B in gram per dm cube, 28.6 gram. Now I want you to do this. In concentration of B in mole per dm cube, I made use of 25.0 centimeter cube. I want you to try it and use 20.0 centimeter cube. You are going to be getting 0.1 also. So try that. And we calculated the molar mass of Na2CO3 H2O. And the molar mass was what? 286 gram per mole. And then from there, we go on to calculate the value of X in this compound. So I wish you success and good luck in your coming GCE exam. And then if this is your first time watching us, you are welcome to the Scholar Online class. And don't forget to subscribe. After subscribing, click on the notification button so that you can get a notification when we drop a new video. Thank you very much.